We're in Rosen 13.3 on finite state machines with no output or finite state automata. We've covered the procedures for crafting a deterministic finite state automata that is equivalent to a non-deterministic finite state automata. And we will carry out the procedures to create the DFSA that recognizes the same language as this NFSA that we had seen earlier in the chapter. And remember, our starting point is to create a starting state with a set containing S0, and in this case, since in the NFSA it is a final state, it'll be a final state in the DFSA. We'll call the NFSA M0 and the DFSA M1, consistent with the procedures we saw earlier. All right, so in S0, if a 0 comes in, it goes to two different states. It goes to state 2 and state 0. So we create a new state with the states containing S0 and S2 as the label for our new state in M1. And it's an accepting state because S0 is an accepting state in M0. And in S0, if a 1 comes in, it goes to state 1, so we'll create a state in M1 that has the set containing S1, and it is not an accepting state, so it stays only with a single circle. And that's all possible inputs for our for our starting state in M1. Okay, so now with in M1, if the state containing S0 and S2, if a 0 comes in M0, S0 goes to S2, S2 goes nowhere, S0 also goes to S0, so this will stay in that state for M1. If a 1 comes in, S2 goes to S4, and S2 goes to S4, and S0 goes to S1. So this will go to, we'll create a new state for S1 and S4, and that will be an accepting state because 4 is an accepting state. So that's what happened when a 1 comes in for that state. All right, and moving up to the top with state 1, if a 1 comes in, I'm going to go to state 4. So I create a new state for state 4 contained in a set as my label. That is an accepting state, so it gets a double circle. That's if a 1 comes in. Or if a 0 comes in state 1, it goes to state 3. So I create a state 3 set, and that goes here, and a 1 comes there if a 0 comes in. And that's all possible inputs for that state containing S1. All right, for the state containing S4 up top, what happens if a 0 or a 1 comes in? In that case, it just goes to state 3. Okay. And then for the bottom state with state 1 and state 4, if a 1 comes in, it goes to state 4. If a 1 comes to S1, it goes to state 4. If a 1 comes in to state 4, it goes to state 3. So I got to create a new state, S3 and S4. And it's a final state because it contains S4. And that's if a 1 comes in. If a 0 comes in to both state 1 and state 4, it goes to state 3. So that's already created. And now with state 3 and state 4, if a 0 comes in, it goes to state 3. And if a 1 comes in, it goes to state 3. So we'll just draw a 0 and 1 there. Now for 3, state 3 stays with state 3 if a 0 comes in, but if a 1 comes in, it goes to the empty state. So I have an empty set containing as a label for a new state there, and that's if a 1 comes in. Now with this state, it will always just stay there perpetually because there's no transitions in the NFSA for the empty state. And that should be all of our, this is our DFSA equivalent of that NFSA. Notice that it has more states than the NFSA, and indeed it could have up to 2 to the 5th states because that is the size of the power set of all the states of M0. Let's see what language it recognizes. So it recognizes lambda because it starts in an accepting state, recognizes 0 because it goes to that next accepting state, and then it continues to recognize 0 to the n in that state, and it recognizes a 1, and then recognizes a 1, 1 after that. So it looks like we get 0 followed by 0 to the n, followed by a 1, and 0, 0 to the n, followed by a 1, 1. And then also over here, just 0 to the n for n non-negative. And we're missing 1 here because I have 0, 0 to the n, 1, 1, but I can't construct recognition for just 1, 1 by itself, but we can see that that is created along this path here. I get 1, 1. So that means we get 0 to the n, 1, 1, 0 to the n, 0, 1, and 0 to the n. So 0 to the n, 0 to the n, 0, 1, and 0 to the n. 1, 1, which is the language that was recognized by this NFSA as seen earlier in the chapter. And I'll just go ahead and do the build so we can see a more clean representation of that DFSA that is equivalent to the NFSA M0 that we've been dealing with. And you can look at that on your own and see if I made any mistakes in building it. All right, that is how you construct a equivalent DFSA that recognizes the same language as an NFSA.